Hello, in this video I'm going to take you through some of the GMAT probability concepts. Now, probability is one of the most difficult and confusing subjects in the GMAT Math. However, if you're aiming at a 700 plus score, there is no chance but to do it. So at least a basic understanding will help you take an educated guess even if you can't solve the whole question. So in this series of videos I'm going to talk you through how probability works and how to tackle it at the GMAT. So let's get started with a simple definition. What is probability? Probability of an event is essentially the chances of that event occurring. Now, if you look at a textbook, what definition you will find is what you see on the screen here. So, probability is if S is the finite sample space of an experiment and every outcome of S is equally likely, and E is an event that E belongs to S, then the probability that E takes place is defined as NE divided by NS, which basically is the number of ways in which event E can occur divided by the total number of ways that anything else including E can occur. So this is the formal definition. We will soon go to a much simpler to understand definition, but let's see what this formal definition is saying essentially. So if you have a dice, the normal dice with 6 sides numbered 1 to 6, and you wanted to calculate the probability of getting a 2, so this NE becomes the number of ways in which you can get a 2, which essentially is there's only one way here because there's only one dice that you're rolling, and the total number of outcomes, which is the sample space S. So you could get a 1, you could get a 2, you could get a 3, a 4, a 5, or a 6. So the total number of outcomes here is 6. So 6 is your total sample space. So the probability of getting a 2 when you roll a dice is 1 by 6. Simple to understand? Great. Okay, taking on a little more complex example. If you think this is complex, you have to see what's coming next. But anyways, this is an example where we need to find the probability of getting no heads when we toss 2 coins. So in this case, we are tossing 2 coins at the same time. That is to be noted. If we were tossing one coin after the other, the calculation and the process would be different, and we'll probably cover that in one of the later videos when we talk about permutations and combinations. So here we're tossing 2 coins. Each one has a head or a tail. So the total number of outcomes, the total sample space here is coin 1 can be a head and coin 2 can be a head as well. Coin 1 can be a tail and coin 2 can be a head, and so on. So the total number of possibilities you can get is this, which is 4. Any other possibility you can think of you might get when you toss 2 coins? No? Great. So we have 4 possible outcomes here, and we need to find the probability of getting no heads. No heads means both coins should show tail tail, which is the one here. Is there any other tail tail? No. Great. So this is 1, and hence the probability of getting no heads in an event E is number of times event E can occur, which is this one here, 1, divided by the total sample space, which is 4. So quite simply the probability is 1 by 4. I spoke about the easier method of understanding what probability is rather than the textbook method which we covered a while back. The easier method is essentially the probability of an event is defined as the number of ways in which the event occurs divided by the total number of outcomes possible. So this is the core of understanding in a simple way what probability is. So this definition ignores the sample space, the n in bracket e, and all those convoluted and complex looking symbols. It's simply the number of ways in which the event that you want to find the probability of occurs divided by the total number of outcomes possible. Now the advantage of looking at it this way is you can calculate the numerator and the denominator of this equation independently. So let's look at another example. Let us try to find the probability of number greater than 2 this time appearing on a dice. Now the total number of ways in which the event occurs, so how many ways can a number greater than 2 appear? So let's count the numbers that are greater than 2. So you have 3, 4, 5 and 6, and the total of these is 4, and you know that the total number of outcome possible is 6. So the probability is 4 by 6, which is something you can see here. Okay, before we get on to solving the GMAT type of problems, let us look at some important points about probability. Keeping in mind these points will help you not only come to the right answer, but also if you are confused to eliminate at least some of the answer choices. A lot of these are quite intuitive, and we will refer to some of these points later on in the videos when we look at the GMAT problems. So the first thing to keep in mind is the probability of an event A is always between 0 and 1. Probability cannot be more than 1, a key cardinal concept. Probability cannot be less than 0. It can be 0, but it cannot be less than 0, negative. So that's quite intuitive in the sense. Again, let's take the example of rolling a dice. Now, what's the probability that you can get any number from 1 to 6? So dividing the event by the total number of outcomes. So in this case, any number you can get by in 6 ways, number 1, 2, 3, 4, 5, 6, and this is also the total number of outcomes possible. So 6 by 6, which is equal to 1. So any experiment that you can think of while rolling a dice, you'll never get the numerator which is more than 6, because 6 is the maximum number of outcomes that you can get. So that is what this greater than 0 and less than 1 is referring to. Which nicely brings us to the second point, and that is probability of the total sample space is always 1, which is, as we discussed here, the total sample space is 6 in the case of rolling a dice, and the numerator is 6 as well. So PS would be, for example, probability of the any event in the total sample space occurring divided by the number of events in the sample space. And as you can see, this should always be equal to 1, because essentially we're talking about the same number in the numerator as well as in the denominator. And moving quickly to the third point, which is probability of a null event is always equal to 0, which is in a way the inverse of what we discussed in point number 2 here. So this essentially saying that probability of no event happening from this sample space S, there should be a number of ways in which event null can happen from a sample space S is equal to 0. So if when you roll a dice again, what is the probability that you will get none of the numbers 1, 2, 3, 4, 5, 6? I mean, that is 0, because in this experiment of rolling the dice, you will end up with a number because we're talking about rolling a dice, and it's not going to suddenly disappear or get suspended in midair or something like that. So those were the important rules. There are some others like you see below, number 4 and then number 5, but we will cover these more with reference to specific problems that we discuss. Another important concept that we will quickly need to touch upon is the concept of independent events. Essentially, if you have two events, the probability of event 1 occurring is completely independent of probability of event 2 occurring. Then the two events are said to be independent. A classic example is when you toss a coin twice, the probability of getting a head in the first toss and the probability of getting a head in the second toss are completely independent of each other, which means that if you get a head first, that in no way means that the probability of getting a head second is any greater or lesser. It is still in both cases equal to half and half. There are other concepts as well, but the best way to learn is to discuss those concepts when we are actually solving problems. So let us get down to the real job of solving GMAT type problems. So looking at the first example, this kind of an example you might get in the first couple of questions on the GMAT, because this is considered to be an easy one even though it involves probability. So what is the probability that a card drawn at random from a deck of cards will be an ace? Now first of all, what this assumes is that you know in a deck of cards how many aces are there. So you got 4 suits, and each suit, so the 4 suits are spades, hearts, diamonds and clubs, and each suit has 1 ace, which means there are 4 aces. And the question also assumes that you know how many cards are there in a deck in total. And you've got 52 cards in total, divided equally amongst the 4 suits. So your probability is the number of favorable outcomes, which is 4, divided by the total number of outcomes possible in the sample space, which is 52. Because when you draw out a card, the total number of ways in which you can get a card is 52, because all cards are unique. If you take the color and the value on the card, it is going to be a unique, and there are 52 unique cards in a deck, so you get 52 here. And the favorable outcomes is an ace, and there are 4 aces: the ace of spade, heart, diamond and club, and hence there are 4 favorable outcomes that you are looking for. So the probability, as we discussed earlier, is simply the number of favorable outcomes divided by the number of total outcomes. So the probability is 4 by 52, or 1 by 13. Now the same principle can be applied to probability of obtaining different totals from a pair of dice. So for example, you need to find out how many ways can you get a sum total of 2 when you roll a pair of dice. So let's try to do that quickly. The only way you can get a sum total of 2 is when dice 1 has a 1 and dice 2 has a 1. So the number of favorable outcomes is 1, and now you need to find the sample space. How many outcomes are possible when you uh, roll a pair of dice? So that would be 6 numbers possible in dice 1 and 6 in dice 2. 6 into 6, 36. This of course assumes that the dice are different, not identical, and hence a 5 on dice 1 and 6 on dice 2 is not the same as a 6 on dice 2 and 5 on dice 1. Let us look at a slightly more complex example. What is the probability that when a pair were to be noted, a pair, that is, you're talking about 2 instead of 1, when a pair of 6-sided dice are thrown, so it's a normal 6-sided dice, what is the probability that when a pair of 6-sided dice are thrown, the sum of numbers equals 5? Now the first thing in this example is to find out how many ways can you get a 5. So you can get a 5 when you have a combination of 1, 4, or 2, 3, or 4 1 or 3 2. So this is the total number of ways in which I can get my number, the sum of the number on the two dice, to be 5. 1 4 is different from 4 1 because in this case it's the first dice that gets a 1 and the second one gets a 4, and in this case the first one gets a 4 and the second one gets the 1. So the total number of favorable ways is 4. And how many ways are in the sample space, which is the total number of outcomes? So when you roll two dice, the number of ways in which you can get any number on the first one is 6, because it's 1 to 6, and the number of ways in which you can get any number on the second one is 6 as well. So the total number of ways, since these two events are independent of each other, becomes 6 into 6. Now to explain this a little further, let us actually note down a few examples. You can understand this better by looking at it as explained here. Considering that one of the dice gets a 1, then there are 6 possibilities for the other dice. So first dice is 1, second dice could be 1 or 2 or 3 or 4 or 5 or 6. Then again, if the first dice gets a 2, then the same is still true. So there are still 6 possibilities for the second dice. And then if you go on, what you find is that the total numbers you end up are 6 into 6. Now if this is still confusing, we can look at the following abbreviated list of outcomes. So here's 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, and then you have 2 1, 2 2, 2 3. So if you count all these numbers, you'll find that the answer is essentially number of ways in which the events happen on the first dice multiplied by number of ways in which they happen in the second dice. So for example, if the first dice were a special dice which had 8 faces, the total number of possible outcomes would be 8 multiplied by 6, assuming the second dice still had 6 faces. So this is an important concept, and often to find out the total number of ways in which the event can occur, which is number of in the sample space, is more tricky than finding out the number of ways in which the favorable event can occur. So we get the total number of outcomes is 36 and the favorable outcomes is 5, which is listed here again. The probability is 4 by 36, which is the same as 1 by 9. Okay, just to reinforce what we did in the previous example, let us find the probability of getting a 12 when you roll the same two 6-sided dice. Now as we saw, the total number of outcomes remain as 36, which is 6 into 6. And since there is only one outcome that sums to 12, which is 6 by 6, Can't think of any other way in which you'll get a 12 when you roll 2 dice. So the probability simply becomes 1, because there's only one way in which you get the favorable outcome, divided by 36, which is the total number of ways in which you can get any outcome. So the probability in this case is simply 1 by 36. Okay, here is an example which you might, a kind of question you might get on the GMAT if you're doing really well, cruising along at 650 plus, 700 plus kind of levels. So essentially we've got the question here which says there are 30 red and blue marbles in a jar. So there's one jar which has two kinds of marbles, and the ratio of the red to the blue marbles is 2 by 3. What's the probability that drawing twice you will select two marbles if you return the marbles after each draw? Now I've underlined the keywords you need to keep in mind when you're actually solving this question or approaching this question. So the first thing to determine is that there are 30 red and blue marbles and they are in the ratio 2 by 3. So we need to find out how many red marbles are there and how many blue marbles are there. So red marbles would be 30 total, multiplied by the ratio of red is 2 by 3, which makes it 30 into 2 by 5. Do you know how I got the 5? 5 is simply equals to 2 plus 3. And similarly for the blue, it will be 30 multiplied by 3 by 5. So essentially this is so doing the simple math, I get the number of red marbles is 30 into 2 by 5, which is 12, and the blue marbles is 18. Just a quick check that 12 plus 18 equals 30, so that I'm sure that I've not made a silly mistake. So now the question asks me the probability of drawing a red marble 2 times. So let's look at the probability of drawing a red marble the first time. So in this case, how many red marbles do we have? As we just calculated a while ago, we have 12 red marbles. The total number of marbles is 30. So this gives me the probability of drawing a red marble. This is the same as simplifying, dividing by 6 on both sides. You get 2 divided by 5. So the probability of drawing a red marble in the first draw is 2 by 5. Now you notice that the marbles are returned after each draw. So if I draw a marble on the first draw and keep it back, the second time I draw a marble, the probability is the same as it was in the first time round. So the probability, let's say let's call this R1. So the probability R2, which is drawing the red one the second time round, will be again 2 by 5, because the number of marbles and their distribution is exactly the same the first time around as the second time, because we are returning, note the keyword returning the marble after each draw. So the probability we're looking for essentially is the first event and the second event. 2 by 5 multiplied by 2 by 5. Since the two events are independent, the probability is the probability of the first event happening, which is 2 by 5, multiplied by probability of the second event happening. So this gives you 4 by 25, which is the answer. Okay, here is the complete solution in a more formal manner. So essentially the solution is saying we have to do what we've already done. So first look at the ratio and then try to find out the number of marbles of each type. You could possibly set up an equation to find how many marbles of each type exist. We've done it more simply in a direct way. And it's noting that the first draw does not affect the probability of the second draw, since we are returning the marble. So here it finds out the probability of drawing the red marble, which is 12 by 30, 2 by 5. The question is really saying we want a red marble on the first draw and a red marble on the second draw, which is an AND situation. Now intuitively, AND means the probability, the net probability should be a lower probability than if you were taking only one event into account. So AND is a key word, and this can help you eliminate some answer choices if you are unable to solve the question on the GMAT in a more formal way. So essentially probability of event A and B is probability of event A independently and probability of event B independently, which is the same answer, 4 by 25. Okay, I hope you are with me so far. Just to throw a little twist in the story, what if we did not return the first marble back to the jar? What would then be the probability of drawing two red marbles in two draws without returning the first marble? Now in this case, the probability for the first event is still 12 by 30, which is 2 by 5, because the initial situation does not change. However, things change in the second draw, because now we have 29 marbles. So we've drawn out one and not replaced it. There were 30 marbles originally. Now we have 29 left. And we had 12 reds originally, but in the first draw we took out one red, so now we have only 11 reds left. So in a jar of 29 marbles, you have 11 red marbles. What is the probability of getting a red, which is 11 divided by the total number of marbles, 29? So this is the probability of getting a red. Now in the second draw, and in the first draw it was 2 by 5. In the second draw it is 11 by 29. So the total probability would be 2 by 5 multiplied by 11 by 29. So looking at it in a more formal way, here is the explanation, and as it says, probability of getting A and B at the same time is PA into PB, as we discussed before. So 2 by 5 into 11 by 29, which is 22 by 145. So hope you enjoyed this session. Please leave your comments so that we can fine-tune any further sessions based on what you want and what you need. Thank you very much for your time.